episode 55, titled Run Required Penetration Vectors, we focus on the disciplined execution of mandated penetration activities so they deliver insight without causing collateral harm. Penetration vectors are the structured attempts to probe defenses, external network gates, internal trust zones, application logic, and interfaces such as API endpoints, performed under rules of engagement and careful coordination. The work is a technical exercise, but also a governance moment. Every probe must map back to approved scope, timed windows, and contact points so that detection teams, owners, and assessors all read the same signals at the same time. Good execution means the team learns where controls fail under realistic pressure. It does not mean surprise outages or unlogged explosions of activity. Approach the run as a controlled experiment. Hypothesis, method, observation, and conclusion, with traceable evidence and immediate containment options ready.
Validate multi-tenant isolation and cross-tenant data access controls thoroughly because cloud and platform designs often inherit shared services where a single misconfiguration permits data leakage. Map tenancy boundaries, resource pools, namespaces, database schemas, and role mappings, and then design probes that attempt cross-tenant reads, metadata inference, or side-channel access paths such as shared caches, poorly partitioned queues, or misapplied access control lists. Use synthetic tenants and seeded test data to demonstrate leakage without risking real customer information, and craft queries and access sequences that prove unauthorized visibility or modification paths. Log all cross-tenant attempts with timestamps and trace IDs, and include the tenant identifiers and the exact call sequences in evidence packs so reviewers can confirm isolation failures without ambiguity. If the environment includes third-party managed tenancy layers, coordinate tightly with providers to ensure the test windows and remediation paths are clear.
Attempt privilege escalation, lateral movement, and segmentation bypasses with techniques that reflect realistic adversary playbooks while respecting the operational fragility of production environments. Privilege escalation tests should explore misconfigured capabilities, improperly bound roles, and unsafe defaults in orchestration templates that elevate privileges when chained with other behaviors. Lateral movement probes examine whether credentials, service tokens, or reused keys let an actor move from a low-value segment to high-value assets. Plan these attempts to use read-only or simulated actions when possible and to stop before causing persistent configuration changes. Segmentation bypass tests should evaluate firewall rules, microsegmentation policies, and developer bypasses, such as whitelisted IP ranges or tunnel endpoints. Document the exact commands, payloads, and network paths used, and have containment playbooks ready so any unexpected escalation can be reversed quickly without hitting customer-facing services. Exercise input validation thoroughly against common injection classes and deserialization flaws because application vulnerabilities remain among the most impactful vectors. Design test cases for SQL and NoSQL injection across all entry points, including indirect inputs such as batch processing fields or CSV imports. Probe for cross-site scripting in contexts that influence authentication flows or administrative consoles, and check for unsafe deserialization or object injection patterns that allow arbitrary code paths or privilege shifts. Use crafted payloads that mirror known exploit patterns, but start at low intensity levels, observing behavior and validating that instrumentation logs the precise inputs and stack traces where available. For each injection attempt, capture both the raw request and the full server response as part of evidence, and steer clear of payloads known to cause durable corruption in third-party libraries unless a pre-approved rollback and restore plan exists. Respect the rules of engagement, ROE, at every step by embedding throttling, clear stop conditions, and active monitoring coordination into the test plan. Define throttling parameters such as request concurrency, per-second limits, and acceptable error rates tailored to each target class so probes reveal weakness without overloading services. State explicit stop conditions, sustained error rates above a defined threshold, impacts to latency beyond agreed service level thresholds, or the appearance of data integrity anomalies. Coordinate with monitoring teams to ensure that test traffic is flagged and that automated runbooks do not escalate production responses into wide-reaching outages. Make the ROE document a living contract. Include contact points, escalation procedures, and an explicit authorization stamp so everyone from on-call engineers to the Security Operations Center recognizes the tests and the conditions under which they must intervene.
Capture reproducible evidence meticulously. Log every request, response, timestamp, and authoritative asset identifier so each observation can be replayed and validated later by assessors or engineering teams. Use request IDs, full raw HTTP transcripts for application vectors, PCAP or flow logs for network vectors, and command transcripts for host-level interactions, and store these artifacts in a secure, access-controlled repository with immutable timestamps and checksums. Normalize asset identifiers to the agreed inventory keys so cross-referencing is trivial, and include environment markers to show whether the observation came from production-like, staging, or a synthetic tenant. Build a manifest that lists each artifact, its format, the tool that captured it, and the replication steps required to see the same behavior. That manifest is the thread that ties findings to remediation and prevents disputes over provenance later. When high-impact findings are discovered, communicate them immediately, with clear containment recommendations rather than waiting for the full report to mature. High-impact items, active data exfiltration paths, administrative bypasses, or remote code execution demand rapid notification to the system owner, the incident response lead, and the authorizing official. Provide a concise packet, a one-page technical summary that explains the observation, an initial impact estimate, and 3 practical containment options ranked by speed and disruption. Include the exact replication steps so owners can reproduce the issue locally, and suggest immediate mitigations, such as access revocation, temporary network isolation, or emergency configuration locks. Rapid, prescriptive communication reduces the window of exposure and builds trust between testers and operators by focusing on control of harm first, analysis second. Validate fixes quickly and retest vulnerable paths to closure so remediation is demonstrable and not merely aspirational. After owners deploy a fix, run the same authenticated steps, network probes, or crafted inputs under similar conditions to confirm that the exploit path no longer functions. Capture both negative evidence, the absence of the prior exploit result, and the positive evidence that shows the control now enforces the expected constraint, such as a denied response, sanitized output, or failed privilege escalation attempt. When retests are successful, record the retest artifacts and update remediation trackers with the proof links. If a retest fails, escalate with detailed diagnostics that help engineers iterate rapidly. Treat retesting as part of the same run rather than an afterthought, because timely proof closes the cycle and restores normal risk posture. Document residual risk and compensating controls transparently, where unresolved issues remain after the run. Some vectors cannot be fully addressed immediately due to vendor dependencies, architectural constraints, or planned decommissioning. In those cases, describe the remaining exposure, quantify likely impact and exploitability, and name compensating measures, such as increased monitoring, stricter access policies, or network filters that constrain reachability. Tie each residual item to a POA&M entry, or equivalent remediation tracker with explicit owners, milestones, and acceptance criteria. Make sure any compensating control is itself monitored and validated regularly so it does not become a permanent, undocumented bandage. Transparent documentation ensures auditors and sponsors see a thoughtful trade-off rather than a hidden risk. Produce final, vector-by-vector summaries that present severity, exploitation context, and recommended next steps in a format that supports both operational action and executive understanding. For each vector, include a short technical narrative of the path, the exact conditions needed for exploitation, the evidence artifact identifiers, and an agreed severity rating with a rationale tied to impact and likelihood. Add a concise remediation box that lists immediate containment, medium-term engineering fixes, and long-term architectural changes where relevant, and annotate whether retest evidence exists or is pending. Package these summaries so they can be lifted into POA&M, briefings, and triage sessions without rework, because a report that is modular by vector accelerates decision-making and keeps accountability clear at the level where fixes happen. Run a mini-review before closing the testing window that confirms vectors covered, evidence captured, and retests planned so the team leaves no ambiguity about next steps. The mini-review should be brief and documentary, Enumerate the vectors attempted and their status, list artifacts captured with locations and checksums, confirm which fixes passed immediate retests, and map outstanding items to owners and dates for retesting. Share the mini-review note with owners, the incident response lead, and the assessment sponsor so everyone has the same snapshot of what was learned and what remains. This quick reconciliation prevents finger-pointing and speeds the transition from testing to remediation activity. In conclusion, executing required penetration vectors is about rigor, safety, and speed. Rigor in method and evidence capture, safety in coordination and throttling under rules of engagement, and speed in communicating and validating fixes so exposure windows are short. When reconnaissance, abuse case testing, tenancy validation, escalation attempts, injection probes, and authenticated checks are orchestrated as a controlled experiment with clear stop conditions and documented outcomes, the results become trustworthy inputs to risk reduction. The next practical step is operational. Schedule a consolidated readout session with owners, the Security Operations Center, and the Assessment Authority to walk vector summaries, demonstrate replication steps, and translate findings into POA&M entries. That readout is where technical discovery converts into managed remediation and measurable reduction of real risk. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.